Hello, welcome back. So, we are solving the May 26 Time Zone A Paper 1. Now we are solving question 10. I suspect that this is a common question on both the standard and the higher level. Part A. We want to show A is equal to 3 by 2, B is equal to 9. We also know the point of inflection. Very useful information. So, to find the point of inflection, you have to find the second derivative of f, then set it equal to 0. First derivative, second derivative. Now, we know that minus 2, we know that the second derivative at negative 2 is equal to 0 because it is the point of inflection. We also know the y coordinates of this point. So f at negative 2 is going to be this. These guys cancel out, so you're down to this dude. Simplifying the first equation, we get b equals to 6a. Simplifying the second equation, we get b equals to 6 plus 2a. Therefore, 6 plus 2a is equal to 6a. A is 3 by 2. This is a show that question, so please show all your work. Therefore, b is 6 plus 2 times 3 by 2, or 9. Exactly what you're being asked to show. Part B. It is given that the tangents to the graph at x equals to negative 3 and x equals to k are horizontal. This means f prime at negative 3 is equal to 0 because we have a horizontal tangent. So, plug it back into our first derivative. This has to be true. A is 3 by 2. B is 9. So therefore C is going to be 13 and a half. Find the value of K. Okay. So f prime of x is equal to 9 by 2 x squared plus 18x plus 27 by 2. We want to solve this equation and we want to set it equal to 0. So let's multiply everything by 2. Divide everything by 9. And found out that the order value is negative 1. Part 3. State whether f has a local maximum or a local minimum. Well, we know that it is a positive cubic because a is positive. Should look something like this, and this point has to be a minimum. But we are asked to prove it, so here we go. The second derivative is equal to 6ax plus 2b. A is 3 by 2. B is equal to 9. And therefore, the second derivative at -1 is going to be 9 greater than 0. Thus, it is a local minimum. Part C. The graph of f intersects the y-axis at the point P. Show that the tangent to the graph at x equals to -3 passes through P. Okay, so where is P? P is the y-intercept. In other words, P has coordinate 0, d. The tangent to the graph at x equals to -3. Okay, so we know this is a horizontal tangent, and all it is asking us to do is to find the y-coordinate of this point. So f at -3 is equal to I really do not appreciate how I don't really like how this question is too heavy on algebraic manipulation. Okay, B is 9, C is 27/2, oh wait, no, there should be a 9, sorry. There should be a plus 81 minus another 81/2 plus d, so it should give you d. So we know that the tangent line is actually y equals to d, and this passes through 0d. So this is the end of this rather weird question. It's not hard, but it's too much algebra.